So your test is next week. Starts at 5 and goes till 7:30. I will be here at 4, 3, actually 3, 3:30, somewhere around there. So if you want to come away earlier, you're more than welcome to. Yes.
So there, it says you have to go take it.
If you've already passed, if I've already told you you don't have to take it, you don't have to take
But you said it's something to do with.
it. As soon as you got a 90 or above on all 3 of your tests.
I don't believe you got
What was your last name?
the plural.
Oh, you didn't get your other test. Here. You are exempt. There you go. So technically, you don't need to be here because I'm just going to review. You just have to finish your hours.
And that's due when
The 9th. The 9th at midnight.
the not.
Yep, the day of the final. By midnight, the day of the final. So next Tuesday at midnight.
And how what did portion rating said?
40%. Oh. All right. So we'll go through a bunch of this tonight, probably first 8 questions or so, and then we'll do the other ones on Thursday. That's a different one tomorrow. So way back at the beginning, we started looking at limits. These could be any limit. It's going to be a graph like this, and you're going to have to figure out pieces of information from it. So the 4 on here has the limit as x goes to infinity. So what is the limit as x goes to infinity? It's -2. Because that's this line right here. So as x goes to infinity, it's getting closer and closer to that line. As x goes to negative infinity. Yes. That's this one. And those two are considered what? Those are both horizontal asymptotes. So y equals -2 and y equals 2 are both horizontal asymptotes. What is the limit as x goes to 1? What'd you say? Yeah, that's infinity. And as x goes to 3, that is negative infinity. And those are both vertical asymptotes. What's the limit as x goes to -4?
1.
1. Right there. So I can technically ask you any point on the graph. Okay. What's up? Oh, yeah. All right. Oh, you're fine. Thank you. Welcome. All right. Next set of problems. Do some derivatives. All right, find my derivative. Yes. All right, find my derivative of that one. So this one is same thing as saying 5x to the negative third becomes negative 15, x to the negative fourth, which is negative 15 over x to the fourth. 3x to the fifth, it's just 15x to the fourth. This is x to the 1/2, which becomes 1/2 x to the negative 1/2. We got 1 over 2 square root of x. Any questions on those? What's the rule for these? What are the rules? What's the rule we use for this?
Now it's the change, or not the change,
The power rule. Yep, this is just the power rule. All right. Do this one. Yeah, this one you're gonna need the product rule for. What's the product rule? Mhm. So in this problem, f is x plus 7, x to the 1/2. So f prime is g is e to the x, and g prime is e to the x. So we have 1 plus 7 over 2 square root of x times e to the x plus, or you can just write it as e to the x 1 plus either of those two answers will work.
Let me ask you.
Yep.
For the final, the same rules apply as the other test, right? In terms of like simplifying, so like the answers. And,
Yeah, either of those would work. Yeah, you could have left it like that.
What about in terms of like the 7 halves x to the negative power? The negative power, do you want us?
Yeah, get rid of the negative powers.
Get rid of negative, okay.
Yeah. Have the answer looking like the original problem in terms of what it is. So it has square root in it, unless it comes out to be some crazy root with back to the square root. All right, what about this one?
X plus 5 times x plus x. 7x squared.
Yes. However, this is a perfect example where you should not use the product rule. Because you could literally have done this. So always look to simplify the problem down if you can before you start using the product rules and the other rules. That makes life a lot easier. So this one becomes 42x to the fifth plus 25x to the fourth minus 8x to the third. I wouldn't have marked it wrong if you did the product rule, as long as it came out to be right. But look at the problem before you automatically just instantly go to the product. Do this one. What are we going to do for this one? Yeah. If it was flipped over, you should do like you did the where we just did the last one. Distribute it, clean it up a little bit. But since it's the addition or subtractions on the denominator, we can't do that. So we do have to do the quotient. So it's f prime g minus f g prime over g squared. You could possibly clean it up further. I'm not going to expect you to. Any other questions with that one? Sorry, I go back. Oh, you're fine.
Supposed to do live.
No, it can just be Y. It doesn't have to be Y back. You typically see them written as a function of X, but it doesn't have to be. All right. Since you do get a sheet of paper, what my suggestion would be is to write down the derivatives, the function of the derivative, which also would then give you your antiderivative part too. Just write them next to each other because you can go back and forth. Write down all the 6 major trig functions. Actually, in essence, I will show you that. Give me 1 second. I will show you what you're gonna probably need. I just gotta pull the book. You finish this one, I'll pump the thing up in a second. Trying to find the list of derivatives. It's in one nice list.
So does sign affect the derivative of that tangent at all? Or would it just be the derivative of tangent and then it just?
Yeah. It's exactly how you write it. So this table is in chapter 5, section 5.4. That's basically what you'll need. And then obviously going backwards for all of the derivative pieces of those. I can't find a nice one for the derivatives. All right, what do I gotta do for this one? Yeah, we need the quotient rule again. So f is 2x. So f prime is 2. So g prime would be negative secant squared x. So y prime Any questions on that one? I said that's the table that I would have for the integration, and then you can use that to go backwards for some of the basic derivative ones. So like tangent, cosine, sine, cotangent, secant, cosecant, ln of x, e of x. Next, this one we gotta do the chain rule. This is one where simplifying down this does make the problem look a lot nicer. And it simplifies pretty nicely. So. Actually, if you really wanted to, this actually simplifies that to this. That's what it actually simplifies that to. Because it's all multiplied, you can just literally put them all together.
Still acceptable.
Yeah, I'll accept that. Yeah. All right. What about this one? Yeah, this is implicit differentiation. So when we do it, we have to make sure that if you do the derivative of y, you put the y prime. And then we have to solve for the y prime. So what's the derivative of x squared? What's the derivative of 6xy?
It's a sum of 6x and 6, or sum of 6y and 6x y prime.
Yeah, so this one you actually do have to do the product rule for. So 6xy is derivative of 6x, which is 6 times y, plus 6x times y prime. And then 12y squared is 24y y prime. And then you do the derivative of the other side too. The derivative of 28 is 0. Now we have to solve for y prime. So get all your regular ones on one side, get the y primes over there so you can pull it out. So we've got 6xy prime plus 24y y prime equals negative 2x minus 6xy. We can pull out the y prime. And then you divide again. Now this question asks for one extra piece of information. It wants the tangent line at 2, 1. So to find the equation of a tangent line, what do I need? Find the equation of a line, what do I need?
Slope.
Yeah, we need the slope and we need a point. We got a point, so we need the slope. Slope is our derivative, so just plug in the point. -4 minus 12. 12 minus 24. And you can use the point slope form. As your equation.
Cool.
You wrote that, see, it's like 30% right now.
Point slope. If you can't remember y equals mx plus b works too, you just got to actually move it over. All right. How do we find the limit as this goes to 1?
Plug it in.
Yes, very good. Always plug the number in, see what happens. This one does come out to be 0 over 0. So this one we do actually have to, but always check. Never know. So this one is 0 over 0. So we need to do what to it? You do L'Hopital's rule, which means find the derivative of the top and the bottom. Do not do the quotient rule. I've seen that happen too many times. So the top. Technically, this is the chain rule, except the derivative of x minus 1 is just 1. So the chain rule doesn't really end up changing anything in this case. Also, make sure you do the derivative of both the top and the bottom. I did see people only do the derivative of one of them. So now if we plug in 1, we get 1 over 5.
Not that good, but in the event that still get like 0 over 0 or something,
Keep going.
don't use the same rule.
Yep, you can do it as many times as you want. If it never actually ends up working, like if you get down to something where it ends up cleaning everything out, normally as long as it's a polynomial, you'll get to something that works, because eventually it'll all disappear and becomes 1. So, but yeah, you can keep going. Keep going. All right. Find me everything. I believe on my final, actually, I've just broken into a couple questions, and I just have you find a couple pieces of each one. I don't have you finding everything of one, but I figured for the review, find everything of one. It's the same concept. So, how do we find the domain?
Check where X doesn't, or where the function doesn't exist.
Correct. So we're looking where the denominator is 0. So in this case, the denominator is 0 at 0. So my domain is, you can say x does not equal 0. You can say negative infinity to 0, 0 to infinity. You can say it a bunch of different ways. What is the x-intercepts?
For positive one.
So the x-intercept is 0 equals that. So it's where basically the numerator equals 0. So x minus 4 equals 0, where x equals 4. So that's my x-intercept. Your x-intercept or your y-intercept is where x equals 0, which in this case does not exist. If it did, you just plug in 0 to the problem. All right, how do I figure out on the interval where it's increasing and decreasing?
Where the derivative is positive and negative.
Correct. First derivative, positive and negative. Now, this one you actually can do either way. So I would actually just split this up and do this as this. So I took the x minus 4 and put the x squared under each one. Which actually, you know what? In this problem, that actually doesn't help you. And actually might make it harder for you to do the next step. Because in essence, you still have to get, because you actually have to get a common denominator, which is fine. We can do it. Since I've already done it out, I might as well just finish this. So this becomes negative x plus 8 over x to the third. That actually doesn't work out that bad. So you need, so to figure out where it's increasing and decreasing, what do I need to find now? I need to find my critical numbers. So that means where the numerator is 0 and where it does not exist. So in this case, my critical numbers, my critical values is x equals 8 and x equals 0. Then we have to pick a number on each of those intervals and plug them in. So -2 would be 10 over negative, so that's going to be a negative. 1 would be a positive. And 10 is going to be a negative.
Plugging it into.
Yes. Yep. You plug it back into the derivative to find that. And since I'm not asking you for the points, like the mins and maxes, I'm just asking for the intervals of increasing and decreasing. We don't need to plug it back into the original problem. So my interval of decrease, it's decreasing from negative infinity to 0. It's increasing from 0 to 8. And it's decreasing from 8 to infinity. Huh?
I lost my phone case. I had a pocket to check it.
No problem. All right. Next, Find the interval where it's concave up and concave down. So for this one, I need to do what? I need to find my second derivative. So we need to look at my first derivative. Which I'll do the same thing I did before. All right, so now we do the exact same thing. Find my critical numbers again. My critical values are 12 and 0. Same process. So -2 is going to give me a positive. One's going to give me wait, hold on. That's not a positive. That's a negative. One's going to give me a negative. And 15 is going to give me a positive. So concave down from -infinity to -2, or not -2, 0, and 0 to 12. And concave up from 12 to infinity. You cannot say -infinity to 12. The function doesn't exist at 0. Yes, define concave up and concave down, yeah. All right. Local min and local max. How do I find those? My first derivative is 0. So, well, my first derivative has those first derivative critical values, which was x equals 0 and x equals 8. X equals 0 doesn't exist, so therefore that can't be a minimum or a maximum. So the only one is x equals 8. Is it a minimum or a maximum? We can look back here. If it's concave down, then it's going to be a maximum. So that's a max. And we have no minimum. So you plug that back into the original function. So it's a max at 8 and 1/16. I don't want it as a decimal. Give it to me as a fraction.
But wait, because it's bumping down to max.
Yep. Concave up will give you a minimum. The other way you could have looked at it is, since it's increasing into it and decreasing out of it, that's got to be a max as well. So we technically have the first derivative test and the second derivative test you can fall back on to find that one. All right. Let's look at these three. We'll do them one at a time. So when you have this is a definite integral. So you have to find the integral and then solve it. So what is the integral of x to the negative 3/4? What's the power rule for integration? Well, what did we do for the power for differentiation? We subtracted one and brought it down, right? And then bring it down. Yeah. Correct. So if we add one to this, we're going to get x to the 1/4. And we divide by 1/4, which is really 4x to the 1/4. And since it's a definite integral, we're now evaluating that at 16 and 1. So the answer is 4. 13. This one is a indefinite integral. So we're going to do the exact same thing we just did in the last one, except you don't actually have to plug anything in at the end. But what do you do have to put at the end of it? Let's see. So x to the 2.3 over 2.3 plus 11 over 5.5 to the x 5.5 plus c. Yes. It's another indefinite integral. The definite ones have numbers next to the integration sign. So if there's no numbers there, it's indefinite. All right. What about this one? The last one before we went on vacation. This is a use substitution. What's the thing that's annoying? Yeah. So we're going to make that u, and then we do the du of it, which is going to give me negative e to the x dx. So I can move the negative sign over because I have e to the x dx. So what is the integral of 1 over u squared? So that'd be the same thing as saying u to the negative second. Yeah. Don't plug back in yet. We have to do the integral first. So we're adding 1. So it becomes negative u to the negative first, which is just 1 over u. Now we plug back in. All right, I only have two more problems to go. So we can do either, I'm not sure if I'm going to get through goals. We can try. We might. But I'll let you tell me which one you want me to do first. So we've got 10 and 11. So which one, 10 or 11 first? 10? All right, so the one I heard. We're doing 10 first. All right, so we want to find the largest volume the box can have. So the box with an open top is constructed by a 7-foot by 6-foot rectangular piece of cardboard. So how do I find volume of a box? Length times width times height. Good. So I need L, W, and H. So length is going to be what? So 7 foot, but I'm taking away 2x. And the width is going to be what? Correct. Because I have the 2 x's there and an x there. And then my height is going to be x. If I'm looking for the largest volume, I'm looking for a maximum, right? So my suggestion would be I would multiply that out and then just do the derivative on that. Nope, it's equals 46. Positive. All right, so now we got to pick my derivative of that. So I've got 42 minus 66x plus 18x squared. And this looks like total fun. That's not gonna help too much. All right. So now what I gotta do? Find my critical number. So basically set it equal to 0. I don't know if this is gonna factor very nicely, so I would just do the quadratic formula on it. So I've got negative 66 squared minus 4 times 18 times 42. So this is 1332. Take the square root of that. You get 36.5 approximately. So then I have x equals 66 plus or minus 36.5 over 36. Yeah, for the first one. And 0.82. So then if we look at the two values, if I plug in 2.85 to the second, this one, the width, it's going to be negative. And if I actually plug it in the length, it's going to be negative. So 2.85 would not work. So the only one that will work is 0.82. So 5.36. $3.54 and 0.82. So 15.56. Approximately. All right, let's do the boat problem. So here's the dock. Oh, due south this way. So he leaves the dock and it's going away, or 20 kilometers per hour. Has been heading to east at 15 kilometers per hour. So that's a negative rate. That's a positive rate. All right, set up my problem. All right, so what do we got? So what are we looking for? We're looking for the closest, right? So in essence, we're minimizing the hypotenuse, right? So we're using Pythagorean theorem. So we have a squared plus b squared equals c squared. So we have 2a d over dt plus 2b dp over dt c dc over dt. So we know that, what piece of information do we know? Yep. Well, we don't know what A and B are. We know what dA over dt is. Or what's A and B? A and B is not 15 and 20. That's these. Yeah. What else do we know? Okay, how's that going to help me? Okay. Hold on a second. I might be missing something. I think I might be missing something. So hold on a second. I'm just trying to find the problem. Oh, I could do it this way. Oh, that was where we messed up. I knew we did something wrong. We're not using Pythagorean theorem. What's the question asking? Closest. So we're looking at what? Distance. We're using the distance formula. I was like, I knew I mixed something up. It is, but we don't have the information for it. I have a better picture. I'll use this picture. Here's a better picture. All right, so these are the points as they're traveling. So the dock is here. So we want to find our distance formula for this. So distance is x1 minus x2 squared plus y1 minus y2 squared. And if you remember, we did a problem where we said that I can just get rid of the square root and do 2D and it'd be the same answer. So now we can multiply these out. So we have that's 15 squared, 225. Take the derivative. And set that equal to 0. So it comes out to be 0.36. And that is in what? Hours, minutes, seconds, that's hours. So I needed a minute. So this question asks how many minutes after 1 they were the closest. So what do we do? Multiply by 6. So it's approximately 21 minutes. It's 21.6. All right. So that's the whole review. Mm-hmm. So do you want to come on Thursday? Like, I've done the review. So you do not need to come on Thursday.